In this video, I'll show you how to solve the ALEKS problem called calculating the heat of reaction from bond energies. So to help you solve this problem, you are going to need to go to ALEKS's data tab right here and open up the table of bond energies. We're going to need to be taking values from this table to help us solve this problem. I just went ahead and cut and pasted that bond energy data table into this screenshot so that it's handy for us as we work on this problem. So the equation that we're using to calculate this is the change in enthalpy, or the energy, the heat of the reaction, is going to be equal to all of the bonds that are broken in this reaction, and from that we're going to subtract all of the bonds that are made in this reaction. So what we're going to do is add up the energy of every bond that we break, and then from that we're going to subtract the energy of every bond that we make. The broken bonds are coming from the reactants, and the bonds that we're making are going to be the bonds in the products. And it is going to be really important when we're doing this that we pay attention to the stoichiometric coefficients in this equation. For example, this 2 in front of the HCl means that we have 2 HCl molecules, and that means we're going to be breaking 2 HCl bonds, not just one. So for this particular problem, one of the challenges is that ALEKS is not giving us the Lewis structures, it's just giving us the molecular formulas, and that means that we need to visualize this reaction taking place in terms of its Lewis structures. So I'm going to sketch the Lewis structures for this out really quick. I've got HCl, and I have 2 of them. I'm actually just going to write HCl 2 times, and then I have F2. Those are my reactants, and I'm turning that into 2 HF molecules. Again, I'm just going to write HF twice, and then I have a Cl molecule. So I did notice that some of this one is relatively easy, but some of the molecules, some of the reactants and products in some of these problems are kind of tricky. And if you're not really confident about Lewis structures, one thing that you can always do is use the internet to Google Lewis structure. So you could just Google, Lewis structure of HCl, and it's going to pop up for you. And because it's really important that you get the Lewis structure correct, you're not going to get this problem right if your Lewis structure is wrong. So it might be worth your time to just use the internet to double check on these Lewis structures, especially if you don't feel super confident about them. So what we can do is just use our data table over here to find the energies for all of these bonds that we are breaking. We have a HCl bond and an FF bond. HCl bond is located right here. That is 431. The units are kilojoules per mole. I'm going to leave the units off until I get to the very end. So I've got 431 kilojoules per mole for each one of those HCl's. And then my fluorine-fluorine bond over here, that is 159. And these are all of the bonds that need to be broken for this reaction to occur. And then from that, we're going to subtract the energy of all the bonds that we're making. We've got the HF bond, that is 570 kilojoules per mole, 570 plus 570 because we have 2 of them. And then we also have the chlorine-chlorine bond, that is right there, 243 kilojoules per mole. So now we just need to use our calculator to work this out. So one of the things I do want to point out to you is that there are different energies for double bonds versus single bonds. So that is something you want to pay attention to when you're looking these values up. That didn't come into play on this particular version of the problem, but it did on some of the other problems that I was looking at before making this video. So I'm adding up now all of the bonds that I'm breaking, all of my reactant bonds, and I'm also going to be including all of my product bonds. And this gives me an energy, a delta H here, of negative 362. I'm going to bring those units back, kilojoules per mole. The sign is really important. You've got to include that. If it's negative, make sure you include the negative sign. That is my answer. Of course, ALEKS likes to have that decimal point at the end of the number. It wants us to round it to the nearest kilojoule per mole.